Hello and happy Friday. This is Miss Cliffner coming at you with Friday's lesson. It's Friday the 14th, and I'm asking you to take out your planner and write down the homework, which is 3.4a. It's a worksheet that you're going to glue into your math notebook, and it's not due until Tuesday because Monday is a holiday. So you have a nice 3-day weekend to finish your homework. Also, if you didn't take the Chapter 3 quiz, you might want to do that. It can be accessed through Canvas. Also, there's a few students who didn't finish the Chapter 6 test, which also is in Canvas. Remember, that was the test that I gave on graphing in the coordinate plane, and that is still in Canvas. It's under the Chapter 6 module. I won't let you take the Chapter 6 retake until you've taken the actual Chapter 6 test. So let's say next Thursday, you know when I'm going to do the retake. If you haven't taken the actual test, then you'll be taking the actual test, and everybody else will be taking the retake. So we'll all work on some graphing practice next week. And so today's essential question is, how do you use mental math to multiply two numbers? We're going to do some notes, and hopefully you'll find today's lesson pretty fun. All right, so let's start off with a warm-up. The warm-up has to do with some fractions because you're going to see some fractions in some of today's homework. It's not a lot, but I still want to practice adding, subtracting, and multiplying and dividing fractions. Okay, so pause the video right now. Try the warm-up on your own. I'm just going to point out before you pause it that for the addition problem, I gave you common denominators. For the subtraction problem, they're not common denominators, but 3 doesn't have a fraction, it's just a whole number. But remember, what I suggest you do is you line up the whole numbers and the fraction before you start subtracting and sort of get to the problem that way. Okay, remember, and remember when you multiply fractions, we've got the song multiply across. And the song for dividing fractions is when you want to divide, look on the right side, flip that fraction over, and then you multiply. Okay, so hopefully that's enough to get you started on the warm-up. Pause the video, try these on your own. I'm going to go over the answers now. So notice I give you the same denominators, and when you have the same denominators, then you know that you're just adding or subtracting the numerators. And since it's addition, I'm adding 3 plus 5 equals 8. The size of the pieces don't change, it's still fourths. And now I have 8/4 as my answer, which is an improper fraction, which means I need to divide, right? This fraction bar always means divide when we're simplifying fractions. So then I divide 4 into 8, and it goes 2 times. So my answer is a whole number 2. Okay, so when I am subtracting fractions, if I'm trying to take one thing away from 0 things, that doesn't work, right? So I can think about regrouping fractions the same way that I regroup with whole numbers. So I'm going to take this whole number 3 and I'm going to cross it off, and now I'll have 2 whole things. So picture a whole pizza. I just took it, and the size that I have already is halves, so I want to cut it into halves. And when I cut a hole into halves, I have 2 halves. So I'm going to cross off the 0 and replace that with a 2. So that's regrouping with whole numbers and fractions. And now that I have 2 halves, I can take away 1 half, which leaves me with 1 half because 2 minus 1 is 1. And then over here, it's also 2 minus 1 is 1. So my final answer for that subtraction problem is 1 1/2, which you might have figured out with mental math anyways. Okay, so when I multiply across, I check out the numerators and the denominators, and I look for common factors. 6 and 5 don't have any common factors. 3 and 7 don't have any common factors, so I know I can't simplify before I multiply, so I just multiply across. I get 6 times 3 is 18. So maybe you like writing it like this first, 6 times 3 over 7 times 5, and I get 18/35. And I can't simplify. I know that because there were no common factors. All right, so when I flip the fraction and multiply, I get 4/5 times 15/2. And when I write it like this, right, 4 times 15 over 5 times 2, I can now look again to see if I have any common factors to divide out. And there are some common factors. Notice the 5 and the 15 are both divisible by 5. So I'm going to change some colors. I'm going to put a little divided by 5 here and divided by 5 here. And when I divide by 5, 15 divided by 5 is 3. And 5 divided by 5 is 1. So I've already started making the numbers smaller before I multiply across. And the 4 and 2 are both divisible by 2. Remember, you can use your yellow sheet and look for common factors. Divide by 2. Divide by 2, which means I replace that with a 1, replace that with a 2. Now when I multiply across, I get 2 times 3 over 1 times 1, which of course just equals 6. Okay, I hope that was good fraction review for you. Let's go ahead and get started with the lesson. Okay, so today we are learning about the distributive property and some ideas for examples where somebody distributes. Well, first of all, I've got paper dispensers, right? So my paper dispensers distribute papers. Paper dispensers. And really, right, distribute just means to hand out. Amazon distributes packages. So I want you to think of distributing as handing out different things. But really what we're going to do is we're going to be handing out the same number. Okay, so let's take a look at this. Here's Farmer Fred. He has a pen with a turkey and a chicken, and what he's going to try to do is create separate areas for them. But you can see that it literally is one entire pen. So as we go through this, we want to think about the area of the entire pen, and then the turkey pen and the chicken pen on its own, right? So let me go ahead and I'm going to move this over. Obviously, I can put this anywhere I want, but I have to make room for them, right? So let's do this first. Let's put it there. It's almost equal. And then I'm going to type out my questions. Your questions are on the bottom. I'm going to put mine on the side. Area of entire, area of entire pen, area of turkey pen, area of chicken pen. Okay, so here's the deal. When I look at the area, remember area is length times width, and the entire pen, well, first I'm going to count it, right? So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then when I count the width, it's 1, 2, 3, 4, 5, 6. So I have a 6 and I have an 11. Normally I do 11. I do the length first and then the width. But because I am going to be separating this out, right, into 2 separate lengths, I'm going to always write the width first when I'm doing the calculations. So the entire pen is 6 times 11, which equals 66. And I'm going to call it units squared because we're literally counting the squares inside. That's what we do when we count area. And I don't know if it's feet or meters. We could probably picture feet. We could probably picture meter. Probably not miles. That doesn't really make sense for a chicken and a turkey. So now the area of the turkey pen, right? So the turkey, these are both 6. So this distance is not going to change. The length across will change. So the area of the turkey pen is 6 times 6, which equals 36 units squared. And then the area of the chicken, right? So now it only has 5 across because the turkey had 6 across. So this is 6 times 5, which equals 30 units squared. And it makes sense that the 30 and 36 have to add up to 66. So here's what I want to think about. I want to think about this as being 6 plus 5. So when I find the area, what I'm actually looking at is 6 times 6 plus 5. And this is where the distributive property comes in. And the song that says multiply the outside by the in, this is the outside number, and I multiplied it times the 6 here, and then I multiplied it times the 5 here. So that's what we're starting to look at. Okay, so that's one way I could make the pens. Now I'm going to go ahead and erase this, and I'm going to try it a second way, just to show you that, oops, I shouldn't have erased that. I can create my pen with a bunch of different measurements, right? Okay, so now let's say I move this over. Let's say the turkey gets a little bit bigger and it needs a little more room. So I'm going to move this over and I'm going to draw this in so that you can see that. Okay, so now the turkey has more room because it got a little bit bigger. The width didn't change, it's still 6. The total length didn't change, it's still 11. But this time, right, the turkey's got 7, and this time the chicken only has 4. So the entire length is 6 times 11 equals 66 units squared. The turkey gets 6 times 7, which is 42 units squared. And now the chicken gets 6 times 4, which is 24 units squared. So this time, the pens are 6 times 7 plus 4. And you can imagine with a combination of 11, I mean, I really could, you know, if I made the chicken really small, then I could put this pen all the way over here, take that line, move it over here. That seems kind of ridiculous, but I could do 6 times 10 plus 1, right? So there's all kinds, well, there's not an infinite number of combinations unless I go into decimal numbers, right? But we're keeping it with whole numbers. Okay, so that's the first example. All right, whoa, now I've got a second example, but this time Farmer Fred now has some ducks in his pen. So I'm going to be distributing 3 different areas, right? Okay. So you know I'm going to want to find the distance across the whole thing, and let's see if the width is still the same. So I count 1, 2, 3, 4, 5, 6, 7. Okay, this is a different pen. It's now 7 units in width, and let's see what it is in length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the length is 14. So I'm going to grab this from the other. Okay, let me grab this, Control C. Okay, so now I'm going to put this down here. All right, so of course we need to know the area of the entire pen, and you know I'm going to put the width first, right? This one is 7 times 14. Do a little quick mental math on that, 98 units squared. Okay, so this time we've got to separate the 3 birds. And so, you know, again, there's different ways that I could do this. Let's say, which one do we think needs more space? Well, let's take the turkey and give it 5 spaces. And then maybe the chicken is a little smaller, and maybe the chicken only needs 4 spaces. Oops. I'm gonna grab this. 1, 2, 3, 4, which means there are 5 left over for the duck, right? So this time the turkey pen is going to be 7 times 5 equals 35 units squared. The chicken gets 7 times 4, which is 28 units squared. And then for the duck, I also gave it 1, 2, 3, 4, 5. So 7 times 5 equals 35 units squared. So now when we write across the top, I'm going to use a different color. So this distance was 5 plus 4 plus 5. So when I write an expression that represents the area, I do this. I do 7 times 5 plus 4 plus 5. And I know that I can write out this whole thing. This was 7 times 5. So here we go. I'm going to move me so I've got some room. This equals, oh boy, 7 times 5, that's a dot, plus 7 times 4, plus 7 times 5, and altogether that equals 35 plus 28 plus 35, which we know altogether is 98 units squared. Okay, so the distributive property is a way of writing a multiplication problem. It's one number times usually two things in the parentheses. It could be 3, it could be 4. I mean, maybe we're going to do this, and maybe we're going to create a second duck, right? So we could start looking at a bunch of different ways to make this pen. Let's see. All right, and then make this, right? So now I could create 7 times 5. Oh, this poor little duck, let's make it smaller so it actually fits in the pen. There we go. This would be 7 times 5 plus 7 times 4 plus 7 times 2 plus 7 times 3. So I can break up this 14 unit pen to 2 different sections, 3 or 4, and however many sections I make, that's how many times I'm distributing. And remember, a number next to parentheses means multiplication, which makes me think of area, right? Every time I'm multiplying two numbers together, I'm thinking it could be the area of a pen or something like that. So that's why I'm using Farmer Fred as my example. Okay, so now I'm going to generalize. This is going to be kind of weird because you've seen Farmer Fred and you've seen some examples. But the idea is, if I now have something where Farmer Fred's gonna now plant some vegetables and he wants to find his area, we're going to use the distributive property to describe the two areas that we have in our picture, using that idea of I'm breaking it up, and I'm going to put a little plus along the bottom so that you can see that the total distance along the bottom is B plus C. So distributive property is going to look like this. I take the width of A and I multiply it times the length, but the length isn't just one number, it's now two numbers added together. So I do it like this. A times B plus C is equal to A times B plus A times C, because you see the area inside here is A times B, and the area inside here, because this is also A, is A times C. That's the distributive property. It starts looking a little more confusing when I put in variables, but hopefully you're seeing, just like with the first example that we had with Farmer Fred, if this was 6 and then I broke up the pen into 6 and 5, the distance across the bottom was 11, and it was 6 times 6 and 6 times 5. Okay, that's what the distributive property looks like with variables. Again, the key idea in your textbook looks like this. So when you see these little lines, right, some people do it above, some people show it, below, some people show it above. Most people do it below when you see it in textbooks, but if you did this, right, I'm fine with it too. You're showing me that you're multiplying the 3 times the 7 plus the 3 times the 2. Now I want to point out something tricky, that if the operation inside the parentheses is subtraction, then you would subtract that second product, right? All of the examples that I showed you were adding the two lengths together to make the whole pen for Farmer Fred, but sometimes you could subtract. So let's go ahead and continue on with the notes. So here's an example, and this is what you'll see in your homework. I'm asking you to use the distributive property and sort of a mental math idea to find a product of 8 times 53. So here's how I want you to lay it out. I want you to think about the first number 8 is always going to be the width. This won't be to scale, okay? So you'll have to just pretend that Ms. Clifner is giving you something that's not to scale, and it's going to be okay. And then I'm going to break up this length into two numbers that make sense. And so, of course, what makes sense to me, hopefully to you too, is that I would break it up into 50 plus 3, right? The 10s and the 1s. So again, it's not to scale, but let's say I make this be the distance of 3, and at the top I make this be 50. This is like the area model of multiplying. And so what I'm going to do is I'm going to write an equation that says 8 times 53 is equal to 8 times 50 plus 3. So I broke up the length into 50 plus 3. Now I'm going to actually do it on the picture. Well, what is 8 times 5? It's 40 plus the extra 0. So I have 40 plus the extra 0 is 400. Totally want you to multiply with mental math if you can. And then 8 times 3 is 24. So what I'm going to be doing is I'm going to be adding those areas together to get the total area. Whenever you multiply two numbers, for this part of the homework, I want you to think about it as an area model. Okay, so now I do this part where I'm going to be multiplying 8 times 50 plus 8 times 3. So I'm writing out, it's sort of going along with the picture that's up there. And then you get 400 plus 24. And what is 400 plus 24? It's 424. All right, let's do one more example. Now I'm going to break it up in a different way. Again, you can be a little creative if you want to try it a second way. I'm going to do 8, and then I thought it would be good to do 20, 20. Oops, that's not a very good place for that. 20. Got to make the 20s a little bit bigger. 20, 20. Again, not to scale. 20 plus 20 plus 10 plus 3, because that adds up to 53. Forgot to put my plus up there. Okay, so again, this time the equation is 8 times 53 equals 8 times, what am I adding together? 20 plus 20 plus 10 plus 3. Kind of seems like this one's complicating it a little more than it needs to be. This one totally makes sense. This is just to be creative and show you you can do it a bunch of different ways. Okay, so 8 times 20, that's 16. I like to do it up here first just to make sure the math down here is going to match. 8 times 20 is 160. 8 times 10 is 80. And 8 times 3 is 24. Area model of multiplication says you just add up all those areas and that's the total area. But I'm going to write it out here. 8 times 20 plus 8 times 20 plus 8 times, 10 plus 8 times 3, 160 plus 160 plus 80 plus 24. This is 320 plus 80, I know is 400 plus 120, plus 24 equals 424. Shoot, thank goodness they match. Okay, so it's not really all mental math, but it's definitely finding numbers that are easy to multiply. Okay, so here's another example. Let's do 6 times 99. And so remember, I always want to put the 6 here just to make it easy. So the 6, oh, okay, come on. The 6 goes there. And now 99, I just like to break up into 90 plus 9. That's the first way I'm going to do it. Again, not to scale. This will stand for 90. This will stand for 9. 9 times 6 is 54. So this is 540. 9 times 6 is 54. Okay, so my equation is 6 times 99 is equal to 6 times 90 plus 9, which equals 6 times 90, 6 times 9. Obviously, I'm not going to have you do this every single time, but until you get used to understanding what the distributive property is doing, it makes sense to write out the steps. And then if I add those together, I get 594. Okay, now let's think creatively about what we could do for this box here. If I want to do 6 times 99 with mental math. 99 is close to 100, right? So what I could do this time is one of those where I mentioned subtraction. So what if I do this? And what if I say, this is weird, but this distance is 100. Now, there's no such thing as a negative distance, but what if I just make this be a -1? So now I like it because 6 times 100 is so easy, right? I get 600 and 6 times, oh, well, okay, it's not a -1. Let's just think about subtracting it, but it's 6 times 1 is 6. So this time I'm going to pay attention and I'm going to say I'm not adding. I know 6 times 99 is not 606. I'm actually going to take away this distance. So it's kind of weird, but let's see what it looks like. So for my equation this time, I have 6 times 99 equals, it has to match my area model, 6 times 100 minus 1, which is 6 times 100 minus 6 times 1, which is 600 minus 6. Oh, I kind of like this one better. Even though it was weird subtracting, I think it was easier for mental math. So you can, there's not one right way to do these problems. Okay, so now let's try an OU. Okay, here we go. Use the distributive property to find the product of 5 times 41, and you only have to do it one way, right? You're going to make this a 5. You're going to do this as a 40 plus 1. Go ahead and pause the video, try these, and I'm going to show you the answers. All right, let's see, 5 times 4, 20, plus the 0 is 200, that's 5. So writing the equation is 5 times 40 plus 1. Oops, sorry, I forgot to write the first part of the equation, which is 5 times 41 equals 5 times 40 plus 1, which equals 5 times 40 plus 5 times 1, which is 200 plus 5. Oops. Right. 205. All right, so the next example, 9 times 19. Let's make this 9. Ooh, let's do 20 minus 1. You don't have to, but that's what I'm going to do. I'll make this a 1. Minus 1, and I'll do that a 20. Okay, 9 times 2 is 18, and that's 9. So my equation of 9 times 19 equals 9 times 20 minus 1, which equals 9 times 20 minus 9 times 1. So I get 180 minus 9, which equals 171. Okay, so the last thing I need to show you is an example where we're now going to use mixed numbers, right? And so a mixed number, you always want to separate out the whole number and the fraction. Okay, so here we go. The 1/2 is going to be here, and the mixed number is going to be looking like this. Here's 2, and here's my 3/4. So my equation is 1/2 times 2 and 3/4 is equal to 1/2 parentheses 2 plus 3/4 equals 1/2 times 2 plus 1/2 times 3/4. Okay, so now inside here, I'm going to write the 1/2 times 2 over 1. When I multiply across, I get 2 over 2, which I know just equals 1. Here, a little trickier, 1/2 times 3/4. When I multiply across, oh, that wasn't tricky, 3/8. Okay, so this, I'm going to put it over 1, equals 1 plus 3/8, which is just 1 and 3/8. Okay, this is the OYO. I want you to do the same thing. I want you to put the 5/6 over here as the width, and I want you to break up the whole number and the fraction. Those are the pieces that you're going to want to use. So the 1/10 goes here, and the 3 goes here. The equation is 5, 6 times 3 and 1/10 is equal to 5, 6 times 3 plus 5, 6 times 1/10. Okay, when I multiply 5, 6 times 3 over 1, I'm going to simplify before I multiply. I'm going to divide by 3, and when I multiply across, I get 5 halves. I need to remember I need to divide 2 into 5. It goes 2 times with 1 left over. It equals 2.5. And over here, there's not enough room to write it out, but I have 5, 6 times 1 over 10. 5 divided by 5 is 1. 10 divided by 5 is 2. So when I multiply across, I get a small fraction, 1/12. So this equals 2.5. Let's see. 2.5 plus 1/12. Okay. So now I do need to find common denominators. Remember, when I add fractions, I line up the fractions and I line up the whole numbers. There's no whole number here, so I can go ahead and put a 0. The common denominator of 2 and 12 would be 12, because 12 is a multiple of 2. So I'm going to multiply this fraction by a giant 1, which is 6 over 6. And so I know 1/2 is equal to 6/12. So now I can add the 6/12 plus the 1/12. Down here I'm running out of room, but I get 2 and 7/12. Okay, so that's the OYO. I know this video has gone a little bit long, but there was a lot to show you today. I want to show you what your homework looks like. I want to make sure that you can pause the video and use this as an example for how I want you to write out the homework that I'll be checking next week. And so these are the ones that you have. I can go ahead and make sure that you know what you're going to do is you're going to set it up as 8, right? You could do 20 plus 7. You could count this as 30 minus 3, but maybe that doesn't make it easier. And 5 times 88 kind of just makes sense. It's easy to multiply 5, so maybe make this 80 plus 8. That's the idea for the first two. And the second two are fractions, so remember that it's going to make sense to break up a mixed number like this. This would be the 2. This part would be the 2/7. This would be the 4, and this part would be the 1/2. Okay, the last thing I want to show you is this one that says which one does not belong. So I want you to explain your reasoning. You know, just like notice that I see a number next to parentheses, a number next to parentheses. Ooh, I kind of see a number next to parentheses, but there might be something in there that is not part of that pattern, and then number next to parentheses. Okay, so you're doing this in your math notebook. I know you can do it, and I look forward to seeing you next week. Good luck.